In chemistry, a wave usually refers to the wave nature of particles, especially electrons. A wave describes something that shows wave-like behavior, such as having an amplitude, the vertical distance from the midline of a wave to the peak and through. Wavelength, the distance the wave travels during one cycle. The unit for wavelength is nanometer. Frequency, the number of cycles the wave undergoes per second. The unit for frequency is 1 over second, or s to the power of negative 1, and it's called as hertz, Hz. We can find answers by using this triangular formula, which v, in order to find v, you need to f times by lambda. But if you want to find f, you need to v divided by lambda. But if you want to find lambda, you need v divided by f. Electromagnetic radiation is an energy that travels through space as waves. It doesn't need a medium like air or water to travel. It can move through a vacuum. There are two types of light: invisible light, which can be seen with naked eye, and visible light, which can be seen with naked eye. Electromagnetic radiation is the emission and transmission of energy, electromagnetic wave. Formula: speed of waves c equals lambda times v. Speed of light c equals 3 times 10 to the power of 8 meter per second. Dispersion of white light. Dispersion is a physical phenomenon where white light splits into its constituent colors: red, orange, yellow, green, blue, indigo, and violet. This happens when a sunlight goes through a prism.
Planck quantum. Max Planck proposed the quantum theory in 19,000. He stated that the energy cannot be emitted or absorbed continuously, but only in discrete packets called quanta. The energy of a quantum depends on the frequency of the radiation, as shown by Planck's equation E equals hv. This means higher frequency radiation carries more energy. Planck's theory laid the foundation for modern quantum mechanics.
The energy of that emitted photon corresponds exactly to the difference in energy between the two levels, consists of discrete lines of different wavelength. When we apply heat or electricity, this input causes electrons to become excited, jumping from their stable ground state to a higher energy level. Because this excited state is unstable, the electrons quickly fall back to their original lower energy level. As they fall, they must release their excess energy, which results in light being emitted as a photon. When this light is passed through a prism, it split into a series of bright lines rather than a continuous rainbow. Each of these each of these discrete lines corresponds to a specific wavelength and energy transition, revealing the atom's internal structure. White light, which contains all colors wavelengths, passes through a sample of matter, such as a cool gas. As light travels through, atoms in the sample absorb photons that have the exact energy needed to move their electron from low energy state, which is ground state, to a higher excited state. Missing wavelength. Because these specific photons are removed from the light beam, they do not meet the observer. When the remaining light is passed through a prism, those absorbed wavelength appears as a black line. When electricity is passed through a discharge tube filled with hydrogen gas at low pressure, a pink light is emitted. When the light passes through a prism, a line spectrum is obtained.
The hydrogen line spectrum is grouped into different series such as Lyman, and its spectrum region is ultraviolet. Balmer, its spectrum region is visible. Paschen, bracket, and Fan, its spectrum region is infrared.
In order to find lambda, we have to use this equation, which mentions that 1 of lambda equal to variable constant times by 1 over 1 over final state to the power of 2 minus 1 over the initial state to the power of 2. We can find the final state in the question and also the initial state in the question.
Quantum mechanics. In quantum mechanics, quantum numbers are used to completely describe the state of an electron in an atom. Each electron is uniquely defined by four quantum numbers, which is n, l, ml, and ms. Principal quantum number n. It is the main energy level or shell of an electron, and we can determine how far the electron is from the nucleus on average. The higher n means higher energy and larger orbital size, and determines the overall energy of the electron. Next, azimuthal angular momentum for quantum number L to determine the shape of the orbital. Values The values are L equal to 0 and it corresponds to different orbital types, which is L equal to 0 means s orbital, L equal to 1 p orbital, L equal to 2 d orbital, and L equal to 3 is f orbital. Next, the magnetic quantum number ml. It is the orientation of the orbital in space or relative to an external magnetic field. The values of ml determines how many orbitals exist in a subshell. Next, spin quantum number ms describes the spin direction of the electron. The positive 1 over 2 means spin up and minus 1 over 2 means spin down. This explains why each orbital can hold only two electrons, or the Pauli exclusion principle. There are three rules for assigning electrons. The first one is Aufbau principle. The second one is Pauli exclusion principle. The third one is Hans rule. The Aufbau principle. The Aufbau principle states that electrons fill atomic orbitals starting from the lowest energy level and then move to higher energy orbitals. Aufbau is a German word meaning building up, referring to how electron configurations are built step by step. The Aufbau principle works together with Pauli exclusion principle, which means each orbital holds maximum of two electrons and the spins must be opposite, which is positive 1 over 2 is to up, spins up, and negative 1 over 2 means spins to down. The Aufbau principle also works together with the Hans rule. Hans rule is the electrons occupy degenerate orbitals, which means orbitals of the same energy, first, with parallel spins before any pairing occurs. So, what does degenerate orbitals mean? It means that orbitals that have the same energy level. As an example, the three p orbitals, which is ps, py, and pz, the five d orbitals, and the seven f orbitals. So, what is the relationship between Hans rule and Aufbau principle? The two rules must work together and not separately. The Aufbau principle determines the order in which orbitals are filled, while Hans rule determines how electrons are distributed among orbitals of equal energy.
It is defined as a pure substance that cannot be broken down into simpler substance by ordinary chemical methods. Elements are classified into blocks based on the orbital being filled with electrons. The S block consists of alkali metals and alkali earth metals. The P block includes elements from group 13 to group 18. The D block contains the transition metals, and the F block consists of the lanthanides in the first row and the actinides in the second row. The major factor affecting atomic size is the number of electron shells. More shells make the atom larger because the outer electrons are farther from the nucleus. Effective nuclear charge ZEF is the net positive charge felt by an electron. The shielding effect happens when inner electrons screen the nucleus, and mutual repulsion between electrons reduces the attraction. ZEF is the positive charge felt by an electron. It is given by the formula ZEF equals to Z minus S, where Z is the nuclear charge and S is the shielding constant. The shielding constant represents the effect of inner or core electrons that reduce the attraction of the nucleus on the outer electron. As the proton number increase, self increase, this causes a greater attraction between the nucleus and the electron. The electrons are pulled closer to the nucleus, so the size of the atom decreases. The size of ion depends on whether they are cation or anion. A cation loses electron, so the outer shell is removed and the remaining electrons are attracted closer to the nucleus, causing the ion size to decrease. An anion gains electron in same shell, increasing electron repulsion and making the ion larger. For isoelectronic ion, which have the same number of electrons and the same ground state electron configuration, the ion with the higher nuclear charge is smaller. Electronegativity is the ability of an atom to attract electrons in a covalent bond. It increases across a period due to higher nuclear charge and decreases down a group as atomic size increases and the attraction becomes weaker. Ionization energy is the energy required to remove an electron from a gaseous atom. The first ionization energy is the energy needed to remove the highest energy electron from a natural gaseous atom, while the second ionization energy is the energy required to remove the next electron from a gaseous cation. Electron affinity is the amount of energy released when a natural gaseous atom gains an electron to form a negative ion. Atoms with higher electron affinity have a greater tendency to accept electron. Electron affinity generally increase across a period due to stronger nuclear attraction and decrease down a group as the outer electrons are further from the nucleus.